how's it going? We're going to look at ratios and proportions, and I'm also going to throw in there an advanced topic, which is solving, they're called rational equations, and so it can get a little ugly in intermediate algebra. So this is really an intermediate algebra topic. There's part of this that's going to be a review from, say, an elementary algebra, but this is mostly intermediate algebra. So, as you know, a single fraction, 1/2, or if we say 1 to 2, or we can even say 1 to 2 this way, we know what a fraction is. And a fraction is a ratio. And so it's just comparing one something to something else, one number to another number. So it's just a comparison. That's a fraction. But the minute that a fraction turns into a proportion is when you set that fraction equal to another fraction. So this is called a proportion. When you have a single solitary fraction equal to another single solitary fraction, then that is a proportion. When we are working with proportions, that is again a single fraction equal to a single fraction, we're allowed to cross multiply. So I would take, and it doesn't matter like if you do it this way or whatever, you just get it done. I would probably do 2x, 2 times x equal 1 times 6, which is 6, divide both sides by 2, x equal 3. Well, that makes sense because we know that 1/2 equals 3/6. What happens when you don't know, you can't second guess what that number is? So do we follow the same kind of rules? And you do. And let me just also clarify. Here's another equation. That is not a proportion. This is not the definition of a single fraction equal to a single fraction. This is not a proportion. This is some stuff over here equal to some combination of stuff over here. I cannot treat this in the same way that I do this. Again, a proportion is a single fraction equal to another single fraction. This is not what I have here. I've got this 9. I would probably put that 9 over 1. And I can't solve for x easily. I mean, I cannot see and try to second guess what x is going to be. I literally have to use the LCD. I have to look at all these denominators, and I have to multiply each one of these fractions by the LCD. See, we do not solve equations with fractions in them. There's no reason to. Not when we have a method that we can use to clear all the fractions. So this would be something out of elementary algebra that we would do, and we would say, okay, 5 and 2 and 1. What's the LCD? Oh, it's 10. Okay, so what happens is, and remember, when we're solving equations, whatever I do to one side, I got to do the same thing to the other side. Don't ever forget that the fulcrum of this setup is the equal sign. And so whatever I do over here, I got to do over here. Everybody gets treated the same. Everybody must be multiplied by 10. So I'm going to multiply everybody by 10. And 5 goes into 10. 2 times that would be 2x, and that would be 5x minus 90. Yeah, that's a big number, whatever. We can handle that, no problem. Subtract 3x equal negative 90. Divide both sides by negative 3. X equal 30. Okay, so we use this idea of clearing the fractions. But again, we couldn't cross multiply here because we didn't have a single fraction equal to a single fraction. The minus 9, the way that these two terms were originally hooked together by the minus sign, absolutely destroys any possibility that we can use for multiplying using cross multiply. Now, here is another interesting problem. This is out of a notes packet that I do for intermediate algebra. It's in chapter 7, solving rational equations. Again, we eliminate the fractions. We always eliminate the fractions. Multiply by the LCD to clear those fractions. We do not work with fractions. We do not solve equations with fractions in them. And so here is another really interesting problem off of that notes packet. I make notes packets for all my classes that match up to the textbook. This is a proportion. And let me write one over here that's also not, just so we can do another comparative. And you're not going to like this. This is not going to be pretty, but whatever. It is what it is. But just to make sure we drive home the idea, what is a proportion? When am I allowed to cross multiply and when am I not? I see this all the time. People trying to cross multiply when they can't. So just try to always remember, a single fraction set equal to a single fraction, I'm allowed to cross multiply. This is not a single fraction equal to a single fraction. Why? Because these two terms are hooked together with that plus sign, and that's not a single fraction, and it's not going to be. So I would have to use this method of multiplying through by the LCD, we'll do that in a second, in order to figure out what x is. Now, this guy right here is a single fraction equal to a single fraction, and I can cross multiply. And it doesn't matter which one goes on the left and which one goes on the right. You're just simply cross multiplying. Once you know 100%, you're sure you've got a proportion, you can cross multiply, it doesn't matter. I would probably put the 5 and the x plus 2 this way, equal 4 times x plus 1 this way. Why? Because I know that I'm going to have 5x over here, 4x over here. I like to keep the coefficient in front of x positive. So 5x plus 10, distributive property, 4x plus 4. Again, keeping that coefficient, the reason I put the 5 over here was so that I could subtract the 4x from both sides. X plus 10 equal 4. Subtract 10 from both sides. X equal negative 6. You can always go back in and obviously check your answer. Substitute this guy back into your original and just double check it. You know, this is going to end up being 5 over negative 6 plus 1 equal 4 over negative 6 plus 2. So this is going to end up being a negative 5 over negative 5 equal 4 over negative 4, negative 1 equal negative 1. So in fact, it does check and we're good to go. So I don't really spend a lot of time checking my work, but I mean, it can be done that way. But this is an excellent example, again, of a single fraction equal to a single fraction and cross multiplying. This guy is not your guy. He is not a proportion. You're going to have to factor this to find your LCD so that you can multiply through by that LCD. And by the way, it's usually customary when this guy factors that you're going to get x plus 5, x plus 4. What are the factors of 20 that add up to give you 9? Are going to be 4 plus 5 is 9, and 4 times 5 is 20, so you can use FOIL, first, outer, inner, last, to check all that out. So it's no coincidence that these two denominators, these two binomials, match the two binomials from this quadratic. And so for an LCD, we would multiply by this. And so usually how I would do that is I make great big brackets, and I use the distributive property, and I make sure that I do each one. Of course, here the x plus 5s are going to cancel out, so you'll have the 2 times the x plus 4. Here the x plus 4s will cancel, so you'll have the 3 times the x plus 5. Here both of those denominators will cancel into this, and you'll just get the 2x. And then, of course, now you've just got a linear equation, x to the first power. It's going to be super simple. You just distribute, collect like terms. You isolate for x and solve. But this is not a proportion. This guy is. This is a proportion. This is not a proportion. Now, just to throw a little wrench in it, in this particular chapter, in this particular section, there's another problem that is actually pretty darn ugly. And I'll write it down, and then I'll show you. Now, let me just redraw that line. So, I'll be darned. I have a proportion. I have a single fraction equal to a single fraction. But if you think for 1 minute that cross multiplying these two guys and these two guys is going to help you, you're wrong. It's not going to help you. You've got to be smart about when to choose to cross multiply. This is not it. Look at these denominators. There is no way you're going to be able to take, I mean, honestly, come on. If you took x plus 3 and tried to multiply it and FOIL that out with x squared minus 4, this is going to become an absolute nightmare. There's no way you're going to be able to solve this. So when my denominators are quadratics or complicated like this, then there's no way I'm going to cross multiply here. It's just too messy. I really do need the LCD. And of course, this is the difference of two squares, so x plus 2, x minus 2. This guy has a GCF of an x. So thank goodness they share at least the x minus 2 in common. So I identify my LCD as x times x plus 2 times x minus 2. And I rewrite these in factored form, and this is my LCD, and I'm multiplying this guy by that, and I'm multiplying this guy by that. Each time, something is going to cancel out. And so here, the x and the x minus 2 cancel out, so I end up with the x plus 3 times the x plus 2. Okay, that's not pretty, but that's what we've got. Here, both of these cancel out, so I just end up with the 10 times the x. And so I end up with a quadratic, and I actually end up factoring this guy, and I get two answers. Now, I don't know how familiar you are with an extraneous answer, but if I get an answer for x, and I substitute it back into the original problem, 2 squared is 4. 4 minus 4 is 0. You can never, ever divide by 0. So when we get an answer like this, we call it extraneous because the solution that we got, when we substitute it back in, forces me to divide by 0. We toss out that answer, or we cast it aside, whatever. It's extraneous. And so x equal 3 actually does work out, and we can use him. So he's our solution, and this guy is extraneous. But this guy right here, not a candidate for cross multiplying. Absolutely horrendous to even think of it, to even try. And it's interesting because some textbooks only teach this method. They don't even teach the cross multiply method because students get so confused on, well, when am I allowed to cross multiply and when am I not? Honestly, using this LCD method will solve all of that, and you don't even have to think about cross multiplying. So I see a lot of books teach it this way for everything, even this simple problems, even something like this. I would see a book teach this using this LCD. Okay, what's the LCD for 2 and 6? Oh, it's 12. And so you would multiply this side times 12 over 1, and you would multiply this side times 12 over 1. And so, lost my pencil. And so 12 over 2 is 6. And this would be 2x. And so a lot of times cross multiply in some books isn't even included. They just have you multiplying. I mean, we got the same thing. I mean, these are both the same statement. It's just I use the LCD here, and here I cross multiply. And so you'll see a lot of books just axe out this whole cross multiply thing just because it confuses students. And you can do this one the same way. You don't have to cross multiply. Now these come out really nice when you cross multiply. That's a great, neat little linear equation. But you could also do this by multiplying by the LCD. You get the same result. But I do see a lot of books do it that way, where they just stick with this LCD method. But that's just kind of a general basic rundown on proportions and cross multiplying and solving equations.